Hello students, welcome to my YouTube channel Physics with Asam sir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please press the like button. And this gives me more motivation so that I can bring more number of videos for you. So today's topic is projectile when projected horizontally. That means horizontal projectile. So it is the case of horizontal projectile. Look, the basic thing is that whether it is projected making oblique angle, making some angle with the horizontal, or it is projected along the horizontal, ultimately the basic rules are all same. So let us try to understand this concept with the problems, correct? So let me solve few problems related to this kind of projectile so that I can be able to give you a clear understanding what is happening actually. It is actually nothing new, same as the concept what I taught in the earlier video, correct? So watch about an example, okay? Say for example, a body, suppose a person is standing at the top of a building, okay? Suppose a person is standing at the top of a building, and let me draw that building like this. Okay. And this person is projecting a particle with a certain speed along the horizontal direction. Now the question is this. Suppose this person is throwing a ball along this direction. So what will happen? So first of all, assuming the person is throwing this ball with a, say for example, 20 meters per second. And height of the building is given 100 meters. Yeah. Now the question is, number one question is, find the time of flight. Is time taken by the particle to touch the ground. Number two, the velocity with which it will hit the ground. It will hit the ground. And number three, range of the projectile. Okay. So this is the information given. I told you earlier also that this is nothing but a motion in a plane, correct? So what to do? Acceleration of gravity acting in vertical downward direction, and motion, since there is no air resistance, will not consider any kind of acceleration along x-axis. So motion along x-axis is constant velocity. That means what we can write, ux equal to vx. Now look, the particle is projected along the horizontal. That means this is the x component, that is 20 meters per second. And at the time of projection, look, it is projected totally horizontally. So its component along this direction, it is 90 degree. So what we know, 20 cos 90 is 0. That means initial velocity along y-axis 0. So what will happen? The path followed by the particle will be like this. Clear? And what I have to find out here, number one, find the time of flight. For the time of flight, what I am doing, I am taking the motion along this direction, correct? So I told you this in my many videos, always consider the point or the line from which you are projecting that thing, that is the line of reference, correct? If anything goes above it, consider to be positive. If anything goes below it, consider to be negative. If anything goes forward, take it positive. If anything goes backward, take it negative. Correct? Is the usual sign convention. Now, for time of flight, what I am doing, look, the time during which it will strike here, correct? At the same time, it will cover this vertical height. So for vertical motion, for time of flight, I have to use vertical motion, correct? Now, time of flight. I'm considering time of flight is capital H. Now, what is the initial velocity along y-axis? Is 0. Okay. Now, look at this. What we know, this height is known to us, correct? So what I'm doing, I'm using this S1 equal to UYT plus half AYT square. What is SY? SY is this height. But look, it is below the reference level, correct? So I will consider this as minus 100. What is EY? It is 0 plus half AY. It is nothing but minus G, because I told you this G is always negative, and this is T square. Now minus 100, G is 10, so this is 10 by 2, 5 T square. Therefore, T square equal to 100 by 5, that is 20. That is T is equal to 2 root 5 seconds. Look at this, so simple. You don't have to remember any formula, correct? Though, just use the conception, you can get it very easily. Clear? Because in physics, there are so many formulas. If you try to remember all the formulas, correct? Though, so that will become a hectic job. Now, the velocity with which we hit the ground, correct? So let me do one thing. Look, let me draw the velocity diagram vector. Suppose this is the diagram vector, correct? Now, when it reaches the ground, it has two components of velocity, one along this direction and other along this direction. And this is nothing but velocity along x-axis, which remains constant throughout. And this is what? Velocity along y-axis, correct? Now, we can write Vx equal to Ux is equal to 20 meter per second. What about Vy? For Vy, I have to use the vertical motion. For this, I am using this formula Vy equal to Uy plus Ay into T, where T represents time of flight. Clear? Now, Vy is what? Vy, we have to find out. Uy is 0 plus Ay. Ay is nothing but minus 10, because this is G and this is T. Vy equal to therefore minus 10 into 2 root 5, that is minus 20 root 5 meter per second. What is the importance of this negative sign? This negative sign implies that Vy is in downward direction. Clear? Now what I have to do? I have to find out the resultant velocity, correct? That means the value of V. That means this velocity. We know V equal to what? Root over of Vx square plus Vy square, and Vx square is what? It is 20 square, and Vy square is that 20 root 5. 20 root 5 square. So I can take 20 out. 1 root 5 is 5. That is 20 root 6 meter per second. You can check the calculation by yourself also, correct? Okay. Because maybe there may be some issue with calculation, but you have to ultimately check whether you are understanding the concept or not, correct? Now, what is the angle? If I consider this angle to be theta, okay. So what I have to do? Okay, let me take this angle as theta. Okay. You can take any one of this angle, no issue. but I am taking for a moment this angle. Okay, let me theta. Clear? So if I close the parallelogram, tan theta is equal to what? Height by base, height is Vx by, look at this, this is Vy. Clear? This is Vx, tan theta is equal to Vx by Vy. What is Vx? Vx is 20. What is Vy? You have to take the magnitude only, 20 root 5. That is 1 by root 5. So you can get the value of theta is equal to tan inverse of 1 by root 5. Again, and write down it is with the vertical, correct? And what is the angle? It is already given in the diagram. Now the final question is, what is the range of the projectile? So for range of the projectile, we have to use vertical motion or horizontal motion. Obviously, it is along x-axis, so I have to use vertical motion, horizontal motion. So what is the value? R is the range. That is equal to, you can apply this formula, ux into t, where t is the time of flight. What is ux? That is 20. And what is the time of flight? Time of flight is 2 root 5. If I do this calculation, it is 40 root 5 seconds. Is the answer. Clear? So it is so simple. You can solve it in this way. So now I'm not taking a case where projectile projected horizontal. Let me take some few other different cases, correct? So let's do another problem. Okay, look. A problem is given like this. Suppose there is a building 156.8 meter high. A person is standing over here and throwing a ball, making an angle of 30 degree with the horizontal with an initial speed of 39.2 meter per second. Clear? So they are asking a question. Then find the maximum height reached by the ball at the time of flight and the range. Range means the distance of the point where it would hit the ground from the building, correct? The base of the building. So obviously in this case, the path of the projectile will be looks like this. Okay. So let me do one thing. So this is the height, maximum height reached, correct? So look, as usual, it is similar. Split this into two components, one along this direction, one along this direction. So now ux equal to what? It is u cos 30, that is 39.2. Cos 30 means root 3 by 2. And it is, I think, 19.6. 19 to the 38. 19 root 0.6 root 3 meter per second. It is the velocity along this direction. What is the velocity along y-axis? That is u sin 30, that is 19.6 meter per second. Okay. Now let us use the general concept, correct? Not applying any formula, nothing new, correct? First of all, at the maximum height, Vy should be 0, correct? For the maximum height, what I am doing? Vy equal to 0. And I told you, for any kind of motion along y-axis, use the vertical motion formula, and in this case, same. And for the horizontal motion, it is constant since there is no air resistance, correct? So Vy equal to 0. What is the initial velocity along y-axis? Vy, and that is what? 19.6 meter per second. And as usual, Ay is what? Minus g, that is minus 10 meter per second square. So what I am doing here, I am applying this formula. V square equal to u square plus 2 Ay into Sy. Now what is Vy? Vy is 0. What is Ey? It is 19.6 square plus 2 into minus 10. Sy I need to find out, that is supposed to be h. Okay, h. Now what will happen then? 20h, 19.6 into 19.6 Age 19.6 into 19.6 by 20. So what will be the value? Let me check it out. 19.6 divided by 20. It is 19.20. Okay. So the answer will be like this. It is 19.20. So the maximum height reached, if you calculate from the ground, if I calculate this from the ground, the answer will be this. From ground, the maximum height is 156.8 plus 19.20. So 19.20 plus 156.8. What is that? It is approximately 176 meter. Okay, approximately 176 meter. Okay. Now next thing is that the time of flight. Okay. Now for time of flight, again I am using vertical motion. Correct. Now watch it carefully. Okay. Watch it carefully. Let me erase this. Okay, I need space. Okay. So time of flight. Now for look, it is the point of throw. And body is moving up, comes here. That means its displacement is 0. Then comes down. Correct? So if I apply this formula, Sy is equal to ut plus half it square, that is ui into t plus half ay into t square. Now watch, what is Sy? As I told, since it is the level of throw and ultimately the ball is going below it, correct? So Sy is negative and that is minus 156.8. Now what about ui? Look, it is along upward direction, so I have to consider this as positive. That is what? Look, ui is 19.6 into t plus half ay. Ay is what? Nothing but minus g t square. So let me do the calculation, simplify this. Minus 156.8, 19.6 into t minus half. Let me take the value of g in this case, 9.8. So the calculation will be simple, correct? So if I cancel it out, 4.9. Now check this. Minus 156.8, 19.60 minus 4.9 into t square. So 19.6 divided by 4, it is coming 19.6 divided by 4.9. 19.6 divided by 4.9, it is coming 4. So it will be 4t minus t square, and 156.8 divided by 4.9 is 32. Okay. T square minus 4t minus 32 is equal to 0. Now t square, 4 is a 32, 8t plus 4t minus 32 is equal to 0. Take t common, t minus 8 plus 4 t minus 8 is equal to 0. T minus 8 t plus 4 is equal to 0. Therefore, t is equal to 8 seconds and t cannot be negative, so -4 value rejected. Correct? So time of flight is 8 seconds. Now at last we have to find out what is the range. Correct? For range, it is the motion on which axis? X-axis. Now I told you velocity along this axis always remains constant. So for number 3, range is r is equal to ux into time of flight. What is ux? It is 19.623 multiplied by 8. So 19.6 into 8 is 156.8 root 3. Meter. That means this distance is 156.8 root 3 meter. So that's the answer. Okay. Okay, pause the video and check the calculation. Now let's go to the next problem. Okay, now a problem is given. Look at this, a 40-meter tall building. A person from here throws a ball or a body or packet with a speed of 20 meters per second. But in this case, it is not throwing, person is not throwing it horizontally, but directly towards the ground, correct? So making some angle, correct? So 20 meters per second. So what I am doing here, what I have to find here, the point at which the packet hits the ground, find the distance of that point, find the distance of that point from the base of the building. It is nothing but its range, correct? Number 2, time taken to reach the ground. Okay. Now, what to do again? Same thing. Split it into component. One along x-axis, other along y-axis. Doing it like this. It is ux. It is uy. Okay. Now, let's split this component and find the value of it. Correct? Ux equal to, it is u cos 53. Cos 53 is 3 by 5. 3 by 5. And uy is equal to u sine 53, 20, 4 by 5. If we cancel this, 4 3 is 12 meter per second. And if I cancel this, this will be 16 meter per second. Okay. So how the path of this will looks like, correct? Like this. Clear? Now, let me find out the point at which the packet hits the ground and the time taken to reach the ground. So let me do this calculation first, correct? So solving number 2 first, correct? It will make the problem easier. What is that? First of all, because ultimately when you want to find this, the first one, you need to find out the time taken to reach the ground. So let me do it first, okay? So what is that? In order to find the time of flight or time taken to reach the ground, I am taking the vertical motion in account. And I am using this formula Sy equal to Uyt plus half Ay t square. Clear? Now the question is, look, Sy. What is Sy? This is the level of throw. I told you many times it is below it. Since it is below it, I have to consider this as negative. So minus 40. What is uy? What is the velocity along this direction? It is along which direction? In negative y. That means downward, below the level of throw. Correct? That means, look, it is above. I have to consider positive. Since it is below, I have to consider negative. So it is what? Minus 16 t plus half taking ay. A is, in case of projectile, minus g. Always minus 10 into t square. Correct? So if I do this calculation, this will be 5. So minus 40 minus 16t minus 5t square. Okay. So if I do this calculation, 5t square plus 16t minus 40 is equal to 0. So let us apply Sridhar for this. T is equal to minus b. Minus b is minus 16 plus minus root over b square minus 4ac. B square is 16 square minus 4ac means 4 5s are 20 ac. 20 into 40 is 800. I2a, that is 10. Now it is not necessary, it is useless to take the negative value because time cannot be negative. So I am considering this as positive. Minus 16 plus root over of this. 16 square is 256. 16 square is 256. 256 plus 800. That is 1056. Root over 1056 is what? It is 32.498. So let me take it. Let me take this calculation is 30.32.50. Okay, so t is equal to minus 16 plus 32.50 by 10. So it is what? 16.50 by 10. 16.50 by 10. That is 1.65 second. You may check the calculation. Okay. Please forgive me if I made the calculation wrong because I'm doing it fast. Okay. So 1.65 meter per second, 65 second, because it is ultimately requirement is what key, whether you are understanding the problem or not, how to do it. Okay, calculation is secondary for me, correct? Because you have to understand the concept behind it. 1.65 second. Okay. Now the point at which the packet hits the ground. Now what I told you, key, because this component of velocity always remains constant. So this if I consider this as r. Okay, this is r. So what is r? R is equal to nothing but ux into t. What is ux? Velocity along x-axis is 12. Multiplied that by 16.5, sorry, 1.65 second. 1.65. So 12 into 1.65 is, it is coming 19.8 meter. Okay, so this is the answer. Okay, so this is the kind of problem. These are the type of problem they will provide to you. Okay, now let me solve another interesting question. Suppose the question is given like this. Find the time after which the velocity of a projectile is perpendicular to its initial velocity. Perpendicular to its initial velocity. So how to solve this problem? These are all conceptual problem, correct? So let me show you this. Now, watch this very carefully. This is x, this is y. Suppose the projectile is projected, making some angle with the horizontal, let it be theta, with a velocity u. Clear? With a velocity u. Now, watch it carefully. It is u, and this is theta. The velocity along x-axis always remain constant, but the velocity y-axis along y-axis is constantly changing. As a result of which, what will happen? Watch this carefully. The velocity changes, correct? So net velocity changes. So how to draw velocity in a curved path? By drawing tangent at a point on the curved path, correct? So see, if I want to draw a velocity vector at this point, the direction of velocity will be this. If I want to draw this velocity vector at this point, but the question is that at what point, by the time after which the velocity of the projectile, in this velocity, any of this velocity, makes an angle 90 degree with the initial velocity. Look, if I consider this one, is it making 90 degree? Obviously not. So I will not consider this velocity, correct? So what to do then? How to solve it? Look at this. Let me extend this line. Let me explain this line. And let me draw a perpendicular on this line. So this is the point where the velocity vector makes an angle 90 degree with the initial vector, correct? So what I am doing, it will be u and this will be v. Now watch it very carefully. What is the value of v? Let t be the time after which this is happening. So writing it like this, v equal to u plus a t. Correct? I am not using any kind of I cap, j cap, etc. Correct? I am simply using a vector. Clear? Not in component form. V equal to u plus at. This is equation number 1. Now, what is this u? Now we know that if two vectors makes an angle 90 degree with each other, their dot product is always 0. So if I do u dot v, that must be equal to 0. Clear? Now look at this u dot u plus a into t is equal to 0. Now u dot u is what? What we know? A dot a is a square. U dot a into t. Don't put a negative here, correct? Because I have to find out the dot product, correct? Clear? U dot u is u square. And what is the angle between u and a? A means in this case what? G. Correct? What is the direction along which G walks? Correct? Watch. G is acting downward. So I need to find out the angle between u and G. That means A. Here A equal to G. And in vector, what we know, which angle we have to consider? We have to consider this angle, not this. Correct? Because it is always on the direction of the vector. Now it is theta, it is 90. So extrude angle is equal to sum of the opposite angle, intrude angle 90 plus theta. So what we can write, u dot a is equal to u, a dot b is equal to ab cos theta, u, a means g cos 90 plus theta into t is equal to 0. So u dot u is u square. Cos 90 plus theta is what? This is the second quadrant. Minus sin theta minus ug sin theta into t is equal to 0. Now take u common. u minus g sine theta into t is equal to 0. U cannot be equal to 0. Hence t is equal to what? U by g sine theta. So this is the answer. So simple. So whatever may be the problem, ultimately base is same. Okay. Apply the horizontal motion along horizontal axis. Apply the vertical motion along vertical axis. If there is no acceleration along horizontal axis, ignore the acceleration and apply the constant velocity formula. If it is along vertical velocity and acceleration is acting, use the accelerated motion formula. This is simple. This is all about projectile, correct? But the important concept related to projectile, which I am going to discuss in my next video, that is called projectile in an inclined plane. Okay, so in order to understand the concept related to projectile in an inclined plane, please watch my next video. Good day.